Discover the conversations shaping the future of data storage with the LTO Show, the premier podcast for leaders in the LTO tape storage community. Each episode dives deep into the business and technology issues that matter most, featuring pioneers, innovators, and thought leaders who are driving advancements in tape technology, data archiving, and long-term storage solutions.
Welcome back to the LTO Show, the premier podcast for leaders in the tape storage community, where we go deep into the technology, the trends, and the people shaping enterprise tape and long-term data archiving. I'm very excited today to feature an innovative Spectra OSW 2400 optical SAS switch on the LTO Show today. I remember when I first read the initial product announcement a little over a year ago. It was one of those moments that you stop and go, wow, I had no idea this was even a thing. And it made me scratch my head for a little while. I was genuinely amazed to learn that Spectra had engineered a replacement for the conventional storage SAN architecture. Something built around SAS connectivity, which I'd always considered a peer-to-peer interconnect technology. It really stretched my brain cells to think of it as a storage fabric. And it was the kind of stretch that felt good. It's like hearing a new song you really like. It doesn't happen too often at my age. So when it does, you remember the moment. Okay, I'm probably getting a little too emotional over a tech product in the storage industry, but some of you might know exactly what I'm talking about. Anyway, since I started the LTO Show, I've really wanted to do a deeper dive into the use cases and the technology behind this development. And I've really enjoyed learning more from today's guest, Chris Bukowski, the SpectraLogic product manager, about how it works, how it provides many of the same configuration and management capabilities that a fiber channel switch does on a conventional SAN. We're talking fabric zoning to isolate servers and devices for security and traffic management, just like you do on a fiber channel SAN. Multipathing, dual port failover for redundancy, integration with network monitoring platforms like Splunk, and up to 40 tape drives connected through a single one-use switch with over 1 terabit per second of aggregate bandwidth across the fabric. What makes this especially interesting is how Spectra gets the distance. Rather than converting SAS to fiber channel, which adds protocol overhead and cost, they've kept the native SAS protocol intact and moved the signal over active optical cable at the physical layer. That gives you up to 100 meters of reach inside a data center, or more if you need it, with none of the latency penalty you'd take from a protocol bridge. And the switch runs SAS4 at 22.5 gigabits per second per lane, which means it's already forward-proofed for the next generation of LTO drives, well ahead of where LTO 10 sits today. It's really a thoughtful piece of engineering, and it raises some genuinely interesting architectural possibilities for how tape infrastructure gets designed going forward, some of which I think even Spectra hasn't fully marketed yet. So my guest today is the aforementioned Chris Bukowski, Senior Manager of Product Management at SpectraLogic, where he's been leading the development and go-to-market for the OSW 2400. Chris, welcome to the LTO Show. Chris Bukowski, Senior Manager of Product Management, SpectraLogic. Thanks for joining us on the LTO Show.
Oh, thank you. Thank you. It's great to be here.
I've been looking forward to this session for a long time, Chris. I was fascinated when I first heard about your SAS switch hitting the market a year or so ago. So excited to have you on the show and dig a little deeper into it. And I always like to start every interview with kind of the origin story. How creative is that? So if you could take a minute, walk us back to the beginning. What was the conversation inside Spectra that led to the OSW 2400, your SAS switch? Was a specific customer hitting a wall, or did your engineering team see the gap before customers asked?
It was about saving customers money, right? So we have several different libraries, several different tape libraries that Spectra sells, and
Yeah.
from very large to exabytes worth of data down to smaller, rack-mounted libraries, and even smaller than that today. But we found that a lot of customers with the very large libraries were using fiber channel networks, fiber channel SANs, and noticing that fiber channel SANs were almost to the point where the only thing that you were using a fiber channel SAN for anymore was a tape library, and even
Right.
even disk subsystems and things like that were done on the Ethernet network and not so much on a fiber channel SAN. And so we were thinking those SANs can become really expensive, and what's an opportunity to save our customers some money and give them the same functionality that they would see with a fiber channel network. And we came up with this idea for a SAS switch, an optical SAS switch. So three of the things that we get from that SAS switch are just a lot of cost savings, and I can go into that, at a later point where the real cost savings are. So much easier to use than a fiber channel SAN. And now with a SAS fabric, you can actually have the same kind of distances within a data center that you can with a fiber channel network, where in the old days with SAS, you're limited to 3 or 4 meters on a connection. And so it just worked out to be a great advantage for our customers that didn't necessarily want to buy new fiber channel network when they didn't already have one, right? That they
Right.
didn't want to link the library into. And so it's a great cost savings for our customers.
Yeah, and really there is a fiber channel tax today because fiber channel tape drives cost, depending on the latest price increase from IBM, 1,200 or even much more than their SAS equivalents, right? And fiber channel switch ports are considerably more expensive, I believe, today than a SAS switch in your configuration would be. So you
Absolutely.
help people with that tax, right?
Yeah, absolutely. I've done a detailed analysis, and we do this for a lot of our customers where now you're seeing where they're asking us for quotes. Hey, what if we did this library in all fiber channel, and what if we did this library in all SAS? And one of the things we're finding is the SAS tape drives themselves. So an LTO 10 to LTO 10 SAS to fiber channel is approximately $1,000 cheaper for the SAS counterpart. And in the fabric itself, a fiber channel fabric or network compared to a SAS fabric, you can save, it's less than 50% the cost per port. Sometimes we can go down, depending on the configuration, we can go down as much as 70% less cost than a fiber channel network. And that leaves customers with a lot of great options. So like the example that I mentioned before, where customers were asking for a fiber channel configuration and a SAS configuration, we can look at both of those and save them tens of thousands of dollars on a big configuration, where they can look at and they can say, we can save money on our overall installation, or we can buy more tape drives. So when it was, say, maybe a 15 tape drive library with a lot of media that goes in there, and then if they do it in SAS, well, maybe we can do 20 tape drives for the same cost. And that helps their whole system when it comes to throughput and their data movers to the tape library. It's worked out to be a great solution.
I had a note here to ask about, you launched this a little over a year ago, which kind of coincided with the push to repatriate cloud data, move stuff back on-prem, particularly cold archive, where some of the costs people were seeing on cloud storage, particularly around egress costs, were pretty punishing. And I don't know that your announcement at the time was related to this, but do you think the market trends around cloud repatriation are, does it help that they have solutions like this SAS switch that help reduce the costs of implementing tape on-prem?
It does. I mean, in the storage world today, it's all about costs. I mean, the costs have gone up so high when it comes to flash and just spinning disk and even SATA drives and the real cost advantages for cold, warm, cold data, kind of long-term archival storage is the best option is tape. And so we are seeing a lot of attempt. What happened with cloud storage is as people realize, hey, I've got a lot of stuff in cloud storage and I don't want to access it all the time, or I don't need to access it all the time. That's when AWS comes up with this Glacier model. And really behind the Glacier model is tape libraries back there where they charge more for access and less for storage. They have that whole span of how they price things. On one end, it's more for the storage and less for the access, and on the Glacier side, it's less for the access or less for the storage. But every time you access it, it turns out to be expensive. So if you're putting things into the cloud for long-term storage or cold storage that maybe you feel like I'm going to get to the maybe 2 or 3% of this every year is all I'm going to access. And you put that in your budget and all of a sudden you decide you need to access it 7 or 8% of the time or even 10% of the time, your costs, all of a sudden you get extra multi-million-dollar bill from AWS that, hey, that's not what I was expecting here. I'm just putting this data up here. I'm going to access it one or two times in its whole life. So we are seeing a lot of repatriation. We are seeing customers that are saying, hey, how about if I just put a library on site in my own data center, and can I save and save? And you're exactly right. You save on egress fees, you save on access costs, you save on just data migration costs that you might have. And you can have access to anything in a tape library, if it's actually, out of the cartridge, out of the tape drive and in a cartridge that's in the library, that you can have access to the data in a couple of minutes, which is usually quick enough when it comes to cold data.
Now, I bet your ideal customer for the OSW 2400 SAS switch is all your customers, but let's target in a little bit on that ideal customer profile. Is it primarily a retrofit for existing customers who are running a Fibre Channel SAN, or are you seeing more greenfield deployments where people are building tape infrastructure for the first time?
Well, a couple of different ways. So one is there are customers out there that are trying to get off of their Fibre Channel SAN. So they've moved away from it for disk storage and secondary disk storage for SAN, and they might still have some that they're using for their library, and they'd love to be able to get away from Fibre Channel altogether. The SAS switch gives them that ability to put in a SAS fabric that can do basically the same thing that the Fibre Channel SAN can do up to a certain distance. And then there are other customers that don't have Fibre Channel, and when it comes to a big library, their only option when it came to distance was to put in a Fibre Channel SAN, and people kind of try to stay away from that these days. They don't want to put in a Fibre Channel SAN if they don't have one already. And so now we have this option to put in the SAS switch or multiple switches and create a whole SAS fabric that essentially does what a Fibre Channel SAN can do at half the cost.
Chris, before we get to the switch itself, help our listeners understand why tape is so unforgiving about data flow. What actually happens mechanically when the data stream coming in isn't steady?
Anybody who has a tape library has heard of tape libraries that'll do shoe shining or back hitching back and forth. And that comes from the data stream not staying constant with the tape drive itself. One of the things that we've designed into the SAS switch itself is the capacity for the SAS switch is enough that any data stream will be able to keep current and keep constant to the tape drive itself, not alone the tape library, and to many drives itself. So that the switch itself has 48 lanes in a single switch. It's a single 1U switch. And of those, you can connect 1 or 2 ports back to the host, and you can actually keep as many as 40, 36, 40 tape drives streaming through the SAS switch without any hitching or any shoe shining.
That seems fantastic. So on that note too, I noticed that your switch is SAS4, right? And tape drives today are SAS3. So on the surface, it seems like a speed mismatch, but how does you alluded to it just then, but how does the fabric handle differences between host side and drive side speeds while maintaining this steady streaming rate for tape?
Well, there's a couple of things built into the switch that we use. But one of the things I should mention is that in the tape drive world, we pretty much stay with SAS3. And one of the reasons for that is in the SAS4 chips, there was the piece that was designed out of the SAS4 chips that is key to a tape drive installation, and it's called TLR. And
Yes.
TLR is only built into SAS3. So for the SAS4 capabilities for the switch we have in there for future deployments in case TLR is adopted into SAS4 at some point in the future.
Mhm.
It may or may not. I mean, SAS3 speeds are really good enough for tape drives today, and it's just a matter of how many that you can put on the switch itself. And then for SAS4, we'd also use those when we connect the switch up to, say, a JBOD or some SAS disk library, right? So you
Right.
can connect to it with SAS4. Now, most of the drives are still SAS3 also, but in order to accommodate that, there's a couple of different things that are built into the switch. One is EDFB. EDFB is the ability to help, it's a scheduling mechanism, but it helps you to make sure that the load is balanced across the switch, because the switch itself internally works like you have multiple lanes coming in and then more lanes going out to the devices themselves. And EDFB will help you balance that load across the lanes that you're connected to on the devices, whether they be tape drives or disk drives. Today we use SAS3 to the tape drives, and all the tape drives today since LTO 8 have been SAS3. Prior to LTO 8, they were SAS2. So if you have, say, a SAS3 HBA connected to SAS3 tape drives, you don't have anything to worry about. You don't have any contention between different speed levels, and typically those lanes will go to the lowest speed level of the device or the initiator. One of the other things we have built in is what we call data bolt, and data bolt is a buffering mechanism. If you do happen to have a SAS4 host and you're connected to all SAS3 or SAS2 devices, the switch can actually buffer that throughput, so you can push it. The data mover can push the data as fast as it can into the switch, and the switch can buffer that data out to the different speeds or the different devices that are, say, at a lower SAS level, SAS3. So you don't have to have the whole lane connection from the initiator to the target go all the way down to SAS2 or SAS3. But in the tape drive world, and what we're seeing today is most of our installations are LTO 8, 9, 10, the newest drive, and SAS3 HBAs are the cream of the crop for tape.
Yeah.
And then we don't have any of that contention. So you can utilize a single connection back to a SAS3 host, a single port connection that has 4 lanes on it, and you can accommodate full throughput at up to 12 tape drives with a single connection back to the host, where in the old days, before the SAS switch, you had to have a single connection to the host, and it would be in a copper breakout cable, and that breakout cable would go to 4 different tape drives and use a single lane for each of the tape drives. Now we can do that single connection to the host with up to 12 tape drives instead of just 4.
And so you walked us a little bit through how EDFB works, but essentially it's helping to produce a smooth traffic flow into the tape drive, a more consistent stream. I find it interesting too that you mentioned TLR support on SAS3, because that's a critical element for LTFS environments, right? Yeah.
It is.
Yeah. So isn't there a known challenge with EDFB where the error tracking burden across many ports can actually eat into the performance benefit? I know you mentioned how a single host can serve multiple tape drives smoothly and efficiently on your SAS switch, but are there some trade-offs for EDFB implementations around the overhead that can offset some of the gain?
Well, not in the tape drive world.
Okay.
In the tape drive world, it's when we're going SAS 3 to SAS 3, there's really no need for it. So there's no need to necessarily do that balancing because you'll typically have the speed of a tape drive is about 400 megabytes per second, and the speed of a particular lane is 1.2 gigabytes per second, right? So you can actually have multiple tape drives on the same lane if you wanted to. And for where it really comes into play is more of if you're doing a SAS 4 connection or a SAS 3 connection to multiple devices that are sharing the load, and you don't necessarily have the capacity for all the devices, all the disk devices that are on the other end. And so EDFB stands for earliest deadline first with batching. So it's really just a fancy name for to help do the load balancing and the scheduling when you're connected to a few lanes to many lanes in the SAS fabric.
Interesting. Early deadline first batching? Is that what I heard?
Early deadline first with batching, right?
Oh, first with batching. Okay. Great trivia question. That's a great question to ask at a bar.
Yeah,
You'll get
right.
them every time.
Yeah,
I love it.
and then that in combination with DataBolt, you have what DataBolt allows you to buffer, right? To do the buffering, and those two elements really allow you to keep. It helps you get a best case streaming with your data mover and all your data to your devices.
Yeah. Now, I've kind of been dying to ask because in my research for this, it seemed pretty clear to me that what's been done that's really cool here is it's a SAS switch, SAS fabric, but the physical layer is running over multi-mode fiber or single mode fiber or something so you can get that distance. Is that basically what's going on here? After it leaves a switch, it's converting to optical for the transmission to the other end and it converts back?
Yeah, I mean that's all done. It's all done within the active optical cables and the connectors itself. So
Yeah.
it's multi-mode fiber, right? It's not single mode. It's multi-mode fiber, and it has a unique connectors on the end that make it so it's all within the cabling itself. Now all you have to know in the HBA or in the switch itself is that it has enough power to the ports to be able to handle that active optical cable or that active optical signaling. And all the HBAs that we use here at Spectra are that way. But there are some out there that don't have the power necessarily to drive an active optical cable. Now, one of the things too on tape drives is until LTO 10, I think through LTO 9, LTO tape drives couldn't handle an active optical cable. They don't have that power built into the connector to be able to handle that. But with LTO 10, I'm pretty sure that is there now. So if you wanted to, you could go ahead and connect an active optical cable from the switch to the tape drive itself. But most people don't do that because typically what happens is the switch itself will be right next to the library or built into the library itself. And then you have copper cables that are connected to from the ports on the switch that are connected to the tape drives themselves. And the active optical cable is from the switch on the other side of the data center where your servers are, where your data movers are.
Yep. So, and on that note, I was thinking you could have taken a different approach. You could have converted SAS to Fibre Channel and back. You could have just gone with a straight Fibre Channel implementation over regular Fibre Channel cabling, and it could have given you some longer distances than you support with the unit today, right? What did you gain by staying at the native SAS protocol layer? And where does that approach make the most sense versus longer distance alternatives like Fibre Channel?
There's always overhead involved in changing protocols.
Mm-hmm.
So if you're changing from Fibre Channel to SAS or SAS to Ethernet or whatever, there's always some performance overhead in doing those transfers. And we found that we get our best performance and our best all the way back to what you said about the shoe shining and all that with the tape drives and back hitching. In a complete SAS network or a complete fiber network, you get much less overhead for that protocol transfer or that protocol change. And so that's why we've kind of seen better performance when we create a full SAS fabric to a SAS tape drive than if we put in a bridge that say connected SAS tape drives to a fiber channel network.
So the 100-meter range of your SAS switch, is it working for most real-world use cases where the customer wants the library to be in a separate location, for instance? It hasn't been
In fact, we have a
constraint for you.
No. So there's a couple of pieces to that is we have different optical cables at all different distances, 30, 50, 100 meters. And that's for a single connection between an HBA and a switch, or between two switches. So you can create a SAS fabric with cascading switches and we've tested up to 1 kilometer. So you can actually string these switches together like repeaters in a SAS network and have 100-meter cables between up to 10 switches and be able to, and that gives you great flexibility for your fabric all the way across your data center. If you had to move SAS around and your servers are in one rack over here, but your tape library is all the way on the other side, but maybe you need to connect to some JBODs here in the middle, you can create a fabric of multiple SAS switches, all connected through to the same host, multiple hosts. You can have failover, multi-pathing through the switches to each of the tape drives, because the tape drives do have dual ports. They have dual SAS ports, dual fiber channel ports, right? So you can connect that way. But it's a great way to get extra distance beyond the 100 meters themselves. And that's been huge for our customers, is just the flexibility to be able to have your servers on the other side of the data center from where your tape library is, or maybe even in another room, because you have maybe a special environment room for your high performance servers than you do for your tape library.
Chris, here's a use case I just referred to. I've been thinking about that. I haven't seen you really market this strongly yet, but modern tape libraries at exabyte scale really benefit from being in a dedicated, controlled environment. LTO 9, LTO 10 drives are more sensitive than ever to temperature, humidity, particulate contamination, etc. And a HEPA-filtered, positive pressure, precise humidity control environment can be hugely beneficial to the performance and the longevity of tape backup systems. Now, IBM recently announced a Diamondback library climate control model where they essentially put an air conditioner on the back of the library wherever it goes. I kind of think of that as the spacesuit model, right? But the OSW 2400 enables something architecturally different. You can put the library in a purpose-built controlled room, run your SAS connections to it off your switch or switches to wherever your servers live, up to 100 meters away. And I kind of think of that as the boy in the bubble model. And I think it seems more cost effective. Is that a deployment model you've seen any customers explore built around your switch?
It is. I mean, we do a great job of handling the environmentals in our libraries, and we try to minimize the effect of any sort of variables in the environment that way. But one of the things that the switch allows now is that if you do decide to put your exabyte size or your large library in a specific room or in a specific area that has more air conditioning or less, the side note is that sometimes high performance servers don't live in the same environment that your tape library does, right? And so what you can do is you can put the switch there, and you can move those servers, those high performance servers, off to another part of the data center or even another room. And we have seen customers that are looking at that. In fact, we have one situation or one proof of concept that's going on right now where the customer has servers in multiple different rooms in their building, and the library is in a separate room, and we've got 100-meter cables going from different servers all over their building into a SAS switch that's going to connect to their library. and the library is in a different environmental room than the servers are. And it's in a way, it's what you're talking about. So it's a way to isolate that without having to have, in a SaaS environment today, the servers and your data movers have to be right next to your library. And we don't have to do that anymore.
Yeah. And I also noticed, I think Black Pearl, the most recent version, added support for the OSW 2400. And since Black Pearl manages both disk and tape in your tech stack, so it's kind of connecting the fabric then in my mind. Are you seeing customers extend this SaaS fabric beyond tape into these adjacent storage tiers where maybe a warmer cold storage tier on disk might be SaaS attached using this switch sitting in front of the library? Or is it still, has it extended to adding disk into the mix for the connectivity for this device?
It is. With the Black Pearl, you have, the Black Pearl is a object storage platform, object gateway as we call it. And what it is it's a great object storage platform where you can go petabytes worth of disk or flash on the Black Pearl itself with a gateway to a tape library. So object based tape. And so now in your object storage platform or your object environment that you can have quick access to disk or flash within the Black Pearl itself, or integrate with other systems too, other object storage systems. And you can also you can have your cold storage, or you can set up policies where as something gets to a certain age where before you would roll it off to Glacier and AWS or something like that, you can roll it off to your tape library and you can get it back as quick as a couple of minutes, right? And on the disk, you can get it back in milliseconds, right? So it's helped us to expand the flexibility of that whole environment where you can have the Black Pearl and your object storage gateway in one part of your data center and be able to have the distance to get to other disk subsystems, other SaaS JBODs, or to a SaaS tape library.
Well, and in today's environment where spinning disk, SSD is really hard to get, tape will probably become a warmer tier of storage. And to do that, it has to be enabled with a caching layer of disks, such as Black Pearl accomplishes, right? And then it makes sense that it would be part of that same SaaS fabric for the connectivity. I also want to ask too,
It is.
do you have any early customer deployments or real world installations that you find of interest that surprised you about how they used it? Anything that stands out?
I think the biggest surprise that we're getting out of this is how receptive people are to going with a SaaS fabric where because it's a new thing, right? I mean,
Yeah.
the SaaS world has been direct connections and point to point connections to either JBODs or again to tape on the smaller scale. But one of the things we're seeing is great receptiveness to reducing the cost of having to do fiber channel, and that's been pretty common. In particular, I think the thing that surprised me too is as customers hear about this, it's like, all right, well, give me a quote compared a fiber channel subsystem, SAN with my fiber channel library and a SaaS library. And when they really look at the benefits of the SaaS fabric can do everything that the fiber channel fabric can, except for going miles.
Right.
And when it comes to within the data center, they're looking at that, and then they're saying, you know what, with my budget, I was budgeting for this fiber channel setup, and now I can do a SaaS fabric setup, and I can actually buy more tape drives, which helps my data movers, which helps my data flow, which helps my whole workload, and I can get more done in less time for less money.
Chris, SaaS has always had a reputation of more of a kind of server-based technology. Now that you've broken the distance barrier with your new SaaS switch, how does that change the conversation? Could a customer under 100 nodes actually build a low-cost, high-performance SaaS fabric for their entire data protection tier, not just the tape? Kind of like I was mentioning before, do you see this potentially expanding across more of the disk storage tiers in some data centers?
At some point, I think it will expand even more as people see the benefits of how you can create a SaaS fabric and that it can do almost everything that a fiber channel fabric can do. Initially, we're rolling this out strictly for Spectra tape libraries, but it will definitely expand into more of a full data center fabric kind of role. And one of the things that we built into the SAS switch itself too is you can zone in the switch just like you can with a fiber channel SAN. So you can do whatever you need to when it comes to isolating particular servers and particular tape drives or particular libraries. And there's that data isolation is a great security feature to be able to keep different servers away from even seeing the other servers on the network itself in the fabric. And we also have the ability within the switch to to uh, to integrate with networking applications like Splunk or things like that can monitor your network and see where there's the traffic, and you can get updates on your SAS fabric into those kinds of applications.
I also wanted to ask, because you guys sell Atto's bridge product, their Ethernet bridges. Do you see the SAS switch replacing some of your dependency on these third-party Ethernet switches?
Maybe not necessarily. With the growth of the SaaS end of the business, that's as more companies are moving away from fiber channel, we see it just as a way to make sure that we're positioned to be able to cover all of that kind of that 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 new business aspect of it. So we have, there's the SAS to fiber channel bridge that Atto has, and there's also the Ethernet to SAS bridge that they have. And we use those in several of our installations. In fact, we have one where we've got an Ethernet connection from over 200 kilometers away to our library through that same bridge, which we used to call the swarm. And so we still sell those when it's right for the customer. But as more customers are looking at newer fabrics as opposed to adapting to older fabrics or existing fabrics, the SAS switch comes into play more and more often.
And I was also wondering, if you go into an environment where a customer has a legacy fiber channel SAN, it's fully paid for and amortized, switches, HBAs, people who know it on staff, are they open to talk about a new SAS fabric for the storage area network?
They are. In fact, we have some customers looking at, they have a full fiber channel library, and they want to keep what they have on their fiber channel SAN, and they want to expand the library with SAS. And they're going to use that. So it takes a single HBA for up to 12 more SAS tape drives. It connected through the switch and with all the distance advantages that you have. And one of the things you'll see too is, like you mentioned before, the expense per port for a fiber channel SAN, right? Sometimes that can be as much as $2,000 per port when you talk about the cables and the HBAs and all the connections that you have to make. And we're seeing that the per port cost on the SAS switch can be less than half that cost, if not 25% of that cost, right? 75% discount. And so when we show that to the customers, they're like, well, this is all working. This fiber channel piece is all working. I'll keep that. But when it comes to expanding, I'm going to look, as opposed to buying another fiber channel switch. And if they have dual porting, they've got to buy 2 fiber channel switches. And as opposed to doing that and spending $2,000 a port, approximately, they can do it with SAS for less than half the price. And so you mentioned that before, but that's one of the things that surprises me too, is we've got a lot of customers, several at the moment, we're looking at expanding their fiber channel libraries with SAS, and not necessarily converting the whole library to SAS, but keeping their investment in fiber channel, but their future growth plans go with SAS.
So LTO 10 drives ship today with 12 gig SAS3 interface. We kind of covered that earlier in the conversation. Plenty of bandwidth for 400 megabytes per second native transfer rate. But the OSW 2400 switch runs SAS4 at 22.5 gigabytes per second, already a full generation ahead of the drives it serves today. I'm sure Spectra was thinking, we're going to build lots of headroom into this switch so it'll support future generations, right? Can you expand on that a little bit for us? How you looked at the overall bandwidth, aggregate bandwidth of the switch in terms of the LTO ecosystem?
Sure. So we went with SAS4 because the chip itself can handle SAS3 and SAS2 also at the same thing. So it makes us future proof, right?
Yeah.
So we can actually handle the growth in the future of LTO drives that might go to SAS4. Again, there's the TLR question for that, but if the drives go to higher speeds, they might go to SAS, even stay at SAS3 or SAS4 and go to 800 megabytes per second when it comes to kind of compressed speeds on the tape drives themselves.
Yeah.
And then as disk drives go to SAS4, we have all that capacity built into the switch. So a customer that buys the switch today can actually knows that all that is built in, and all they would have to do is maybe go to a SAS4 HBA and handle, any SAS4 devices on the end. So future proofed in that sense. But when it comes to the LTO roadmap itself, you've got LTO 11 that'll probably be out in a couple of years, and it might be faster. If it does have the ability to run with TLR in SAS4, we're already positioned to be able to handle all of that, and we'll
Yes.
we'll be in good shape to accommodate any of those bigger, faster drives.
Yeah, and that's an interesting aspect to me because I've kind of been quizzing IBM every opportunity I get about LTO 11. We've talked about it on the LTO show before. Western Digital they published a paper about the 64 channel head design. IBM kind of acknowledged that that might be next, and since they've been on the 32 channel head for a few generations now, it continues to make sense. The question, though, is will they double the bandwidth to 800 megabytes per second, or will they stage it? And now I'm kind of hearing that they'll probably stage it. They won't give it all away at first, which we understand. But yeah, it's a great story for the SAS switch that it has more than enough capacity in terms of aggregate bandwidth and individual channel bandwidth to support that kind of new throughput. And personally, I'm excited about what a significantly faster drive could do in today's data center environment with some of the performance requirements we have due to the massive amounts of storage people are needing to support. And again, back to my earlier proposition that tape will move up from strictly a cold tier to maybe a warmer tier of storage enabled by these faster speeds that you support with your new SAS switch. So, hey, I wanted to walk through some quick math for our listeners.
Okay.
As an example, future looking, you got 40 of these LTO 11 drives, and let's say they're running 800 megabytes per second. Let's say they just give it all up at first, right? That's about 32 gigabytes per second of aggregate throughput. The OSW 2400, based on my calculations, delivers 108 gigabytes per second across the switch's fabric, right? Which is about
That's SAS4.
3x the head. Is that about right? Okay, cool.
Yes, that's SAS4. Yes.
Yeah, it's S4, assuming they work that out, which is about 3 times the headroom needed for those full 40 drive LTO 11 deployment at double the speed of drives today. So I guess we already covered it, but does that level of headroom align with how you think about scaling for future generations with this product?
Yeah, absolutely. I mean, it's if you think about the SAS3 world today, the drives are 400 megabytes a second, and you've got 1.2 gigabytes per second per lane, and we've got 48 lanes in there. So a single lane by itself could handle 4 tape drives at full speed, right? So
Yeah.
if they double the tape drive speed to 800 megabytes a second, a single lane at SAS3 can still handle that no problem, and you can still do 48, or 40 drives with a couple of connections back to the host itself with no performance degradation, full throughput, and not have an issue there at all. So then if you make the jump to say the 800 megabytes a second is with a SAS4, and we solve the TLR issue itself, the SAS switch is completely capable of handling all of that throughput and still have as many as 40 tape drives connected at a single time.
Yeah. I wanted to, on that note too, talk a little bit about a hyperscaler question, right? So, um, a lot of people outside of our space don't fully appreciate how much tape is probably running inside a hyperscale environment. Meta's storage team has publicly talked about exabyte scale tape archives. Can you give us a sense of what that world looks like, what role tape actually plays in these hyperscale infrastructure environments at that scale?
Yeah. So one of the data points we like to use is especially in these hyperscale and AI environments, so once the data is processed, there's as much as 60 some percent of the data becomes cold, right? So you use it once and then you have it you process it and it's it's perfect for sitting on cold storage or cold to warm kind of storage for access. We have environments where we have systems in exabytes of data that's already on tape, and with all of that in a hyperscale environment, all of that has access within a couple of minutes to be able to get to that cold data, where you don't have to put it on high cost NVMe, high cost flash, a high cost spinning disk that also can't handle that data for longer periods of time. I mean, a tape cartridge can handle 25, 30 years worth of storage sitting in a tape library. And to have that access to that data with that quality of durability is really second to none when it comes to a tape library. And so we'll see as the massive amounts of data get created, that just means that the amount of cold data mushrooms into even more need for something that's on-site ready access, maybe not immediate access, but kind of an archival cold storage that is economical and can last for decades.
Chris, this has been a fantastic conversation, and I think it's one of those episodes that listeners in the tape storage world are going to come back to. What struck me most is how far the thinking goes here beyond a simple hardware product. The OSW 2400 isn't just a cheaper alternative to the Fibre Channel switch, it's a rethinking of how tape infrastructure is architected. The ability to zone the fabric, support multipath and dual port failover, integrate with monitoring tools, cascade switches for extended reach, and run the whole thing over a native SAS protocol without conversion overhead, it's a serious fabric story. And with SAS 4 already built in, the switch is positioned to handle the next generation of LTO drives. For our listeners who want to explore further, product documentation and specs are at spectralogic.com. We'll have a direct link in the show notes. The full transcript of today's conversation will be posted at ltoshow.com, where you can also find our full episode library and some thought leadership articles in our LTO Resource Center. We thank you for listening to the LTO Show. We'll see you next time.
You've been watching the LTO Show. Thanks for joining us. The LTO Show is produced and written by Pete Paisley. Thanks to our sponsors, these guys and these other guys. Don't miss our next episode coming soon. We feature industry leaders in data archiving that supports LTO storage.